in deeply forested areas like the Edgemont Trail in Maysville, you need LIDAR to penetrate the few gaps in the leaves to the forest floor to get the best DTM result. And that's what we have in this case. We've overlain these Google images using download Google Maps and applying them to this tin. And if we remove the images showing the forest and just go to pure flat textures, you can see the final result of the merging of Kentucky LIDAR with a measured field survey of the trail as currently graded and slightly expanded from its original dimensions. So let's go through this process, how it occurred. We started in P3D. Here's the Ohio River. Here's downtown Maysville, and the area of interest is shown here. Now what we did was we used a special command specific to Kentucky where we can download and import Kentucky LIDAR files. And if you know the map that applies, you can enter it, the tile that applies to your site. And many times you have to enter several, like E342 in addition to E341. And then you can merge them by selecting one and merging it with others that exist in the list. And then finally, you can crop it using the crop command. Let's get out of this download option. You can select the merged point clouds, and then you can draw a polyline in the area of interest, which we have done. That's this polyline here. And then you can use, when you select the merged point cloud, you can use the crop command there. Now, that cropped point cloud was then saved. The point cloud, just a series of dots, was saved and then brought into the CAD. And go to the civil module. There's a wonderful option to merge a point cloud with a tin, a second tin, which in this case was a detailed geoid-based survey of the trail as built. So we can illustrate how this was done. You could start a new project, and we'll call it Trail 2, and we'll import the large cloud that came from P3D. And that was this one as cropped. Now, it's not been merged in to the field surveyed trail as of yet. So we hit OK, and we're going to get the scene up on the screen. And there is that point cloud brought into the point cloud module. And then we can go to the Action tab, and on that entire point cloud, we can make a tin file. We'll just click on the tin. And by the way, to do this, it is often best to pick a perimeter. So what we'll do is use a perimeter and just pick along the entire outside edge of the area of interest, going down this road valley here, and then right click. That area is highlighted, and now you can make a tin out of the selected point cloud dots. And we will just click OK for the default. You do have to give it a path. So we'll come in here and call it trail system and we'll call it Trail 2. Now hit OK, and away it goes. It does it fairly fast. There's a lot of points in here, and it's written the file. You can see it down in the command history. Now you can literally exit. You could save the scene or save the entire point cloud operation, exit after the saving, and go to the civil module where we have some utilities that allow us to merge our field surveyed tin with the overall tin that we just made, the DTM we just made. That's conducted under surface pull down triangulation file utilities. We load the big tin we just made, Trail 2, and with that loaded, it looks really good, really good. You can see the road and the houses on both sides. Here's Skyline Drive, here's Edgemont Road, and Old 68 runs down the hill down below. And now what we're going to do is go next and go straight to the merge tin option. The second option is what we want. It basically substitutes inside a second tin. So the second tin would be the measured trail December 8th. And now it is conducting the merge, but it will complete it. And then we go save as, and this is Trail 2 merged. We save that tin, and you can see what a nice job it did. When we spin this around, that trail running up the hill has been, you can see the top of it right there, and here's that same top up on Edgemont, and because of the LiDAR quality, it's virtually a perfect fit on the site right up to the edge of pavement of Edgemont Road at top. That's the entire process. We will exit and then illustrate the fact that over here in Precision 3D, we actually return to Precision 3D. There is the merged site with that beautiful trail shown here. And if you want to distinguish watersheds feeding a very small pond, let's just hover over this pond. Look in the upper right. Depth of 2 feet, 2.2, volume of only 117 cubic feet right there, where an existing head wall is in place. That's a setting that if you go to the storm event and pull down under the Property Explorer, you can see we will show ponds with only as little as 2 feet of depth and as little as 115 cubic feet of water. With that volume, small volume, will isolate the watershed that feeds it. So in this way, running this command, hitting the lightning bolt icon, we've isolated that watershed and can put in a culvert using this command from the low point across the road. And here we have a 19-foot, 7.87 slope, and it looks like a 15-inch culvert was put in. Go back to the CAD, and you'll see that in reality, an 18-inch CMP was used there, and the length was 15.22 feet, very similar to what we just did on this surface. And that's actually what's in place there. We can switch it over to CMP, change it from concrete, which is the default, to corrugated metal. And because we've switched to corrugated metal, the 15-inch still works, but the headwater is getting close. What if we change that to calculate headwater and force an 18-inch? Watch that yellow headwater line come down. So that's actually what's in place. And this result is extremely similar to what was measured in the field. And further up, there's another watershed where we've actually duplicated that particular, in the same drawing, we've duplicated that particular culvert pipe precisely. The precise length, the precise slope. And that is what went in place there. And it positions itself realistically on the site. Such is the accuracy of the Kentucky Lidar with a field survey superimposed.